So volume by shells. So firstly, let me give a definition what is a shell. So just imagine you have a just a piece of paper, right? And basically it looks like vented like a can. So, or you have an empty can, right? So, empty can. You have an empty can. No top, no bottom. Okay. It's empty, hollow inside, so empty can. It's still three-dimensional object, right? It still has a volume, so it's volume. I'm going to put approximately equal to. So again, just look at that piece of paper. Look at the okay. So what we do is we kind of catenate, right, along the height. So we catenate along the height, and then we flatten it on the ground. Okay, so we cut it, and we flatten it on the ground. And then we calculate volume. So we cut, so that's our cut. And then they flatten on the table. Then volume approximately equals to surface area, which is area times height. So let's calculate that. So we have this side. Now, if you look at the original picture, that corresponds to, so this side, that corresponds to, you see that original circumference. So circumference, and you recall that is 2 pi r. Okay. This side corresponds to this side, right? So it corresponds to height. So it corresponds to height. So what we got so far is area equals to 2 pi r, and I'm going to use h for radius. So what I mean here is h, and from here to here is r. And height is, it's going to be thickness of a piece of paper. So how thick that piece of paper is. So to mark the thickness, we're going to use, because to measure the thickness, again, we go to our original shell, to our original can. So we measure how thick that piece is, measure how thick it is. So what we do is measure outside radius, outer radius, and we measure inner radius, and define their difference, right? So that's what we can kind of do. So height is thickness, which is outer radius, minus inner radius. So that is, we're going to be using letter delta R for it. So that's the volume of a shell. Volume of a shell or empty can. And we said approximately equal because when we flatten that piece of paper on the table, there are these edges, they don't have to be necessarily 90 degrees. So there is some small error. That's why it's approximately equal. That's why. So volume of a shell. That's a formula which you're going to be using in a second. Now let's see what kind of situation we're going to have. So we're going to have a region. So we have a region. We have a region R. some kind of a region. Not sure what kind of region. That's region R. Okay. And we are rotating it around some axis. Okay, it might be x-axis, it might be y-axis, it might be anything else. So we're rotating it around y-axis, or rotating around x-axis, or rotating around anything. Axis of rotation. Axis of rotation. So we have a region, we rotate it. Then what we'll do with our region is the following. Instead of rotating whole region at once, what we'll do is we're going to divide it into small strips. So what we do is we're going to divide it into small strips. Okay. So we're going to divide it to small strips. Okay. And then we rotate only one small strip at a time. So we're rotating only one small strip at a time. Imagine. You're going to see that type of picture. Okay. Then volume is going to be equal to approximately sum of small volumes, those pieces. And each of those pieces is going to be shell. And volume of a shell, as we discussed just a second ago, 2 pi r h delta r. And I'm going to mark r I h I. Therefore, volume, to get exact volume, I take those shells to be thinner and thinner. So make them to be thinner and thinner and thinner. So we're going to get integral r equals to a, r equals to b, 2 pi r h dr. And that's formula for volume by shells. So that's volume by shells formula. R bounded by r bounded by y equals x squared, y equals 2x is rotated around. We'll do it both ways. Y-axis, b x-axis. Find volume over solid of object of rotation. First thing I will do, I'll draw a graph. I'll draw a region. So y equals to x squared and y equals 2x. So that's the region R. That's the region R. And that intersection point, so we have 2x equals to x squared. So we get x equals to 0 and x equals to 2. So this point has coordinates x equals to 2 and y equals x squared, or 2x. We're going to get this point has coordinates 2. And this intersection point has coordinates 0. Figure out what is going on with this region. Okay. Now let's do rotation. So now let's do rotation. Again, we draw the region. Right, so we work on part A now. So we draw the region. Okay. now I will rotate it around y-axis. So instead of rotating the whole region, I mean, yes, it will be maybe nice to have a picture, but we don't even bother much about the picture here. What we'll do is, instead of rotating the whole region, I'll just imagine I will divide the whole region into small pieces, small stripes, right? So I'll divide it into small stripes, right? So I'll divide into small stripes, and then I'm going to pay attention only to one small one. Okay. So technically, I will have a bunch of those stripes. So instead of rotating the whole region, I will see what's going to happen to this small stripe. So small stripe. And when I rotate it, I'm going to see the shell. That's the shell. So I did draw a stripe parallel to axis of rotation. I rotated that stripe, and I obtained the shell. Then volume is going to be 1 over formula 2 pi r h dr. R starts here, R ends there. So let's have a formula. All what we need to figure out, what are the limits for R, and what is R, and what is H. Okay, let's look again at our graph. Let's look at our stripe. When I draw a stripe, it has two endpoints. Okay, so it has two endpoints. And because it's a vertical stripe, so it's going to have the same x. So those 2 points are going to have the same x. And one point is higher than another, so then the over point, so one is going to have y top, and one is going to have y bottom. Okay. Now, if you look at our shell, then you see that height is from here to here. So height is from here to here. So height equals to vertical difference between 2 points, right? And to find the vertical distance between 2 points, we do subtract corresponding y coordinates. So that's y top minus y bottom. Okay. Now to see the radius. Radius is from here to here. That's radius. Radius is horizontal distance, and radius is horizontal distance toward y-axis from a point. And horizontal distance is measured x coordinate of a point responsible for horizontal distance. So radius equals to x. Okay, so radius is x. H equals y top minus y bottom. Limit of integration, where we start making our stripes. And we make our stripes starting here, and we finish, that's the last stripe is going to be somewhere here. So if you look at our graph, so we started somewhere here, and we finish stripe somewhere here. So x is going to be changing from here to here. So x is going to be changing from 0 to 2. And now what we have that information, we can rewrite our integral. Yes. Volume integral r is x, so x equals to 0, x equals to 2 pi x y top minus y bottom, which is h dx. Okay. Now, all that is left now with this integral is kind of do u substitution, because the dx insists that everything should be in terms of x. Should not be too difficult. I'm not saying it's going to be easy, but should not be too difficult. So let's see. Y tops comes from a straight line y equals to x. Y bottom comes from that parabola x squared. So we have y top equals to x, y bottom equals to x squared. So we take them and correspondingly substitute. And then we'll do substitution. And eventually we get integral, so volume equals integral x equals to 0, x equals to 2 pi x. Y top is x after substitution. Y bottom is x squared, x. 2 pi, absolutely. Y top is 2x. I'm not sure why y top is not. So thank you. Y top is 2x, not x. I looked at the wrong function. I should have looked more carefully. So y top is 2x, so it's 2x here, squared here. So we're going to get 2x cubed over 3. So we're going to get 16/3 minus 64. So we're going to get 2 pi times 4/3, I believe. So 8 pi over 3, something like that. And again, don't be surprised if you do the problem once you got a mistake, like we just did. I've forgotten that my function is not y equals x, but y equals to 2x. So somehow I didn't pay attention to that. So that was part A. So now let me try to do part B. See if I will be able to succeed with that. So we still have the same region, right? Y equals x squared and y equals 2x. So we know intersection point here, 2 and 4, 0, 0. And now we're going to rotate it around x-axis. Okay. So if you do, so instead of rotating the whole region, I'll divide the region into stripes, right? I will divide the region into stripes, parallel to axis of rotation. And when I choose one stripe, thin enough, so I will do one thin enough, and then I will rotate only one small stripe, say this one. So I'm going to pay attention only to one stripe, and I'm going to rotate only that stripe. So if I rotate it, I'll get something that looks like this. Okay, and that's going to be shell. Shell. Then total volume is going to be volume. It's going to be equal to integral r start somewhere, r and somewhere 2 pi r. So, and as in the previous case, all what you have to do is figure out what are the limits of r, what is r, and what is h. So when I did my initial stripe, it will have two endpoints on when it intersects, right, with the region, so two endpoints. Because it's horizontal, it's going to have the same y in different x. So I'm going to call it x left y, x right y. Point to the right, point to the left. Okay. And now I will express r and h in terms of those points. Okay, in terms of x left, x right, and y. So height is from here to here. That's the height. So height is horizontal. To find horizontal, we'll have to look at the x coordinates of the points. So it's horizontal distance between 2 points, horizontal distance between 2 points. It's difference between corresponding x coordinates. So height equals x right minus x left. Radius. Radius is from here to here. That's radius. Radius is vertical. Radius is vertical distance from x-axis toward the point. Vertical distance from x-axis toward the point is y coordinate of a point, r equals to y. So we are ready to write that down. R equals to y, h equals to x right minus x left. Limit of integration. You recall, we start making our stripes at the very, very bottom, and they go, and they stop on the top. So we start making stripes here, and that's where our last stripe goes. So corresponding values of y will be 0 and 4. So r will be changing from 0 to 4. So r will be changing from 0 to 4. So now we're ready to substitute that into the integral and write down corresponding integral. Y equals to 0, y equals to 4, 2 pi r is y, h is x right minus x left, dy, because r is dy insists that everything must be in terms of y. So we need to complete our substitution. So we have to express x right and x left in terms of y. So let's see. X right comes from this curve. And x left comes from here. So x right will come from curve y equals x squared, right? So from here, x right equals to square root of y. X left comes from a straight line y equals 2x left. So x left from here is y over 2. So we're going to take these two expressions and we're going to substitute them for x left and correspondingly for x right. So if we do that, we're going to get integral y equals to 0, y equals to 4, 2 pi y, x right is square root of y, x left is y over 2, dy. And that's a reasonably easy integral. Y equals to 0, y equals to 4. Take 2 pi out because it's constant. multiply y. So we're going to get y to the 3/2 minus 1/2 y squared dy. So we're going to get 2 pi. Antiderivative of y to 3/2 is going to be y to 5/2 multiplied by reciprocal. Minus antiderivative of y squared will be y cubed over 3. 1/2 y cubed over 3. And we're doing it from 0 to 4. Add 2 pi to 5. Square root of 4 is 2, and 2 to 5 is, I want to say 32. Four cubed is, I want to say 64. Okay. So we have 2 pi, 64 over pi minus 64 over 6. We get 2 pi, take 64 out and do 1/5 minus 1/6. So we're going to get 128 pi divided by 30. Maybe reduce it, 64 pi over 15. At least that's what I got. But again, I did that by hand. And when you get to this point, you probably want to double check all the calculations, because that's what I did when I did calculation the very first time.